Good morning, Kasturians. So today we are going to discuss some of the numerical problems based on this chapter, magnetism and matter. Okay, so let us start with the very first question. What does it says? A short bar magnet is placed with its axis at 30 degree with the uniform external magnetic field of 0.25 Tesla and experiences a torque of magnitude which is equals to 4.5 into 10 to the power minus 2 joules. And what we have to find the magnetic moment of this magnet. Okay, so now let us see what are the quantities that are given to us. We are given the angle which is 30 degree, the angle which is this short bar magnet is making in the uniform external magnetic field. Okay, this angle is 30 degree. And what else we are given? We are given a magnetic field of 0.25 Tesla. Okay, as you can see. And what else? We are given a value of torque is given 0.45 into 10 to the power minus 2 joules. And we have to find what we have to find, as we can see in the question, magnetic moment we have to find of the magnet. So how do we denote the magnetic moment? We denote the magnetic moment by this small m. So we have to find the value of this magnetic moment. So we are also already aware of the formula for the torque. When a magnet, short, or we can say a magnet is placed in the magnetic field, it experiences a torque. So what is the formula for that? Tau, or we can say torque, is equals to magnetic moment into the magnetic field into the sine theta, and theta is the angle between the two, that is the bar magnet and the magnetic field. Okay, so from this formula we can find the value of magnetic moment. How we can find? We can simply put this magnetic moment on one side and all the other values this side, and we are already having the value of this tau b, that is magnetic field, and theta. So we will be putting all these value in this formula. So what do we get? We get this type of equation. And when we can simply solve these values, and we already know what is the value of sine 30. Sine 30 is equals to half. Okay, so by solving this this equation, we get the value of magnetic moment as 0.36 joules per Tesla. Okay, which is the SI unit of magnetic moment of the magnet. Okay, now let us move towards the second numerical. Now let us read the second question. What is it saying? A short bar magnet of magnetic moment 0.32 joules per Tesla. This bar magnet is placed in the uniform external magnetic field of 0.15 Tesla. Okay, so now we are provided magnetic moment and the external magnetic field. What next it says? It says if the bar magnet is free to rotate in the plane of the field, which orientations would correspond to its. Okay, if the bar magnet is placed in the plane of the field, we are asked to find the orientations, which orientations this bar magnet will correspond. If first it is placed in the stable equilibrium, and second if this magnet is placed in the unstable equilibrium. Okay, so what we have to find? We have to find the potential energy of the magnet in each case. Okay, so now we can first of all write the values which are already provided us in the question. The magnetic moment, which we can see, is given 0.32 joules per Tesla. And what else we are given? We are given the value of magnetic field, which is 0.15 Tesla. Okay, now let us see the first part of the solution, or we can say first part of the question. We want to find out the orientation corresponding to the stable equilibrium and also its potential energy. So we can say when the bar magnet is placed in the stable equilibrium, so what we can say about its magnetic moment and the magnetic field direction, they will be parallel to each other. So when magnetic field and bar magnet, they are parallel to each other, what we can say about the angle theta between them? It is equals to 0 degree. So we are already aware about the formula for the potential energy, which is minus mb cos theta. So as we can see, the theta is 0 degree here, so cos 0 is always equals to 1. So what we can say? u minimum is equals to minus mb cos instead of theta we are putting 0 degree, and when we are solving it further, what we are getting minus 0 values of this magnetic field and magnetic moment. Okay, so after placing these values in this equation, we can simply solve this equation, and what do we get in the final result? We get potential energy, that is minimum potential energy, as equals to minus 4.8 into 10 to the power minus 2 joules. Okay, now what next we have to find out? We have to find out the orientation or the theta when this magnet is placed anti-parallel to the magnetic field, to the direction of magnetic field, and also we have to find the corresponding potential energy. So we are already aware about the formula for potential energy, that is minus mb cos theta, and what we can say about the direction, that is angle between the two, that is bar magnet and the magnetic field, that will be 180 degree. Now why? Because these both magnetic moment and this magnetic field, they are placed anti-parallel to each other. Okay, so when they are placed anti-parallel to each other, so what will be the angle? The angle will be theta between them. So we can simply, we are already having the value for m, b and cos theta. So we can simply substitute all these values in this equation, and what do we get? We get, see, we can put the value of m, that is magnetic moment, magnetic field, and cos 180 degree. What is the value of cos 180 degree? That is minus 1. And after solving this equation, what do we get? We get the final result as 4.8 into 10 to the power minus 2 joules. Why we are getting here result positive? Because one negative we are already having from the formula, and the other negative value comes from the cos 180 degree. What is the value of cos 180 degree? That is minus 1. Okay, so minus and minus, they get cancelled, and we get the result in positive value. So what do we get the final value for potential energy, which it comes out to be plus 4.8 into 10 to the power minus 2 joules. Okay, so that was all about today. Thank you.